Hello, Southeastern MBA students. The last video showed how to use the MM1 template. So that template assumed that you only had one queue. The MMs template assumes, or does not assume that you can have one queue, so you can have multiple queues in this one. And so the difference is that they have added this line for number of servers or number of queues. So at this point it's set to 1. We can change that. Every time we change that number, we need to hit this macro, which is calculate steady state quantities. Now, you may have a bar up here that asks you if you want to enable macros. Yes, you have to enable the macros in order to be able to use this template in order to complete your homework. So make sure you have the macros enabled, and then every time that you change the number of servers, you need to make sure that you recalculate the steady state quantities. So if we want to change it to 3, we hit calculate. Oh, it won't let me go to 3 because of service rights. It gave me an error that I couldn't get everybody served if I only had that many servers. So going to 5, recalculate the steady state quantities. Okay, so anyway, you've got to recalculate the steady state quantities, and if you get an error that says that you don't have enough servers, what that means is that your customers are going to still be arriving faster than they are being served. So again, that the queue would not be in steady state at that point. It would keep getting longer and longer and longer and longer. So you can't do that. So on this template, you still have to, it still assumes steady state. That means that you, in this case, we can't go to 3 servers because we couldn't, our queue would just keep getting longer. We'd never reach steady state. Okay, so what I'm going to do with you is look at problem 19 in your textbook. Okay, problem 19 is about a supermarket, and the unit of time that they're looking at is customers per hour. So we're going to change this minute to hours. That way, again, remember, you've got to make sure that your unit of time stays consistent. So they are going to serve an average of 18 customers per hour. So that is their arrival rate. Their service rate per server or per line per queue is going to be 4 minutes. Okay, now we can't just hit 4. Why can't we just hit 4? Because our arrival rate is in hours. We have to convert one or the other. In this case, we'll just convert the service rate per server to the rate per hour. So if a customer is served in a queue every 4 minutes, that means that in 60 minutes, they can serve 15. So you take 60, you divide it by 4, it equals 15. All right, so let's hit 1 and see if we can do this calculation with 1 server. Because the question that we're looking at is how many servers should be used. And so we cannot we can't get in steady state unless we have more than 1 server. So let's go ahead and put it to 2 and calculate our steady state quantities. And we can use 2 servers. Now here's where it gets a little bit more complicated. They want us to figure out what is most cost effective. So it's kind of similar to the other problems. As in the other problems, though, you can't do all of these at the same time. So the easiest thing to do here is going to be just to copy and paste some of this information. And we'll copy and paste it to the next sheet. Now, you need to make sure that you copy and paste the values, not the formulas. I'm going to show you what happens if I just do a basic copy and paste. Yeah, see, that doesn't work at all. What we need to do is copy and paste just the values, and then oh, we've got to go back and copy it again. A little Excel quirk. Hold on. All right, we've recopied. And so now we are going to go over here, and when we copy, we're going to make sure that it's the values, and see how now everything magically shows up. Okay, so now we're going to go back to our model, and we're going to see if it's put in the numbers for 3 and recalculate our steady state quantities. Okay, now and pull our numbers over again. Oh, and I did the same thing. I didn't copy and paste my values, so let me copy again and go to paste special and do values. Okay, we're going to do one more. We're going to go to 4. We probably don't need to. We already have almost 86% of people not waiting in line, but we're going to do it anyway, just to make sure. So we calculate our steady state quantities. Now we'll pull these numbers over to our next spreadsheet, or our next sheet. Okay, and I did it again. Got to do the values. All right. Now there's a few other pieces of data that we need to put in, and that is the cost per queue. The problem tells us that it costs $20 per hour to operate each queue. Oh, and I didn't get that in the right line. There we go. Okay. The next cost that we're given is that it costs 25 cents for each minute that a customer spends in line. Now again, this $20 is in hours. All of our numbers down here are in hours. So we have got to convert this 25 cents a minute to a cost per hour. Okay, cost of waiting per hour. So it's 25 cents a minute. We'll put in 25 cents a minute, and that is going to be times 60. Okay, so it costs $15 an hour for a customer to wait in the queue. Now we need to put cost per queue down here, and we will calculate the cost for each one and the cost of waiting. All right, so in this one, the first one, we are going to operate 2 queues, and then each of those will cost us $20. So we're going to make cell B3 here an absolute value so that we can copy and paste this formula easily. Copy and paste it across now. And so it will cost us $40 to operate 2 queues per hour, $60 per hour to operate 3 queues, and $80 an hour to operate 4 queues. Now we've got to calculate the cost of waiting. So it is going to cost us $15 an hour, so B4, and again, make that an absolute value, times the steady state of the number of people who are in the system. Again, it's not just in the queue. They specifically said it cost 25 cents an hour whether they were in line or being served. Okay, if it was only in line, then you would use B18, but since it's in line and being served, we use B17 because we were going to use the entire system. Okay, so it costs $28.12.5 for a customer to per hour for the customers to be in the system if we have 2 queues. Okay. All right. So now the last step is that we do a sum of the costs. And so it's going to cost us $68 an hour between the cost of the queue and the cost of the waiting if we have 2 queues. Okay. It's going to cost us $79 per hour if we have 3 queues, and it'll cost us $98 an hour if we have 4 queues. So our most cost-effective approach is to use 2 queues even though more customers wait in line. So here you have 55% of people don't wait in the queue versus 85% versus 96%. However, it's still more cost effective. Now, if we change the dollar amount of the cost of waiting in line, so say instead of $15 an hour, now it's going to cost us $40 an hour to wait in line, that would probably change our result. Yes. And so at the point that it costs $40 an hour for people to wait in line instead of 15, now it's more cost effective to have 2 or 3 queues instead of 2 queues. So I hope that was helpful for you. As always, if you have any questions, please call or email me. I am glad to help you. Hope you have a great evening and God bless.